We're going to take all of those properties about exponents that we have been using, and we're going to use them to multiply polynomials. All right, so first we're going to take baby steps. We're going to start by multiplying monomials. So what we're going to do is we're going to multiply the coefficients, then we're going to multiply the variables. So let's take this step by step. I said we're going to multiply the coefficients. Those are my coefficients, the number in front of the variable. I'm going to multiply those, which gives me 18. And then I'm going to multiply the variables. While I'm multiplying y cubed and y to the fifth, my exponent rule tells me that I need to add those exponents. So I've got 18y to the eighth. Okay, that's all I need to do to multiply those two monomials. So let's try that again. I've got my coefficients here, 27. And now I've got two variables that I'm going to have to multiply. So I've got an m here and an m squared here. So I'm going to have an m cubed, and then I'm going to take care of my n, so I also have an n cubed. All right, this one looks a little uglier, but it is doable. I know how y'all feel about fractions. So we're multiplying 1/4 by -12. This one's easy, guys. We don't need calculators. This is just -3. All right, then I've got to take care of all my s's. I've got an s here, that's a power of 2, an s here that doesn't have a power, so it's a power of 1, and another s with a power of 1. So I've got 2, 3, 4. So s to the power of 4. And my t is the power of 2, 3, 5. T to the power of 5. Okay? Yes, I love this one. Okay, so I've got my exponents here and here, or my coefficients here and here. I've got -12. And then how many a's do I have here? I've got 3, I've got 6, and I've got one more, so I've got 7. A to the 7th. B's, I've got 1, plus 2 is 3, plus 4 is 7. So I've got another b to the 7th. And what about my c's? I've got 2, 3, and 8. So there we go. Now, obviously, we're going to get a little bit harder. Now I'm going to multiply the monomial by a polynomial, so we're going to have to use the distributive property. Okay, so I've got this monomial, or constant, that I'm multiplying by this polynomial. This is what we've always been doing, right? We distribute that. Well, there we go. We distribute that piece by piece. So let's go through how we would do that. Of course, it's just 8x squared plus 2x plus 6. It's pretty much what we've always been doing, but now I'm going to throw variables in there. So I'm still going to do the same thing. I'm going to take this and multiply it by this. So I'm going to take this piece by piece. 5r squared s squared, and I'm going to multiply that by just the r. Okay, so what do I have? I have that first part is 5r cubed, because I've got 2 and 1, 5r cubed s squared, and then I'm going to do this piece over here. I'm multiplying the 5r squared s squared, this right here, by the second part of my binomial. So I'm going to multiply it by -3s, so I get -15 r squared s cubed. And notice my bases are, my variables are different because this is r cubed and this is r squared, so I cannot combine them. I've got a subtraction sign in between those. So this is one type of r, these are purple r's, and these are green r's. Those won't combine. Okay, so you've got the opportunity to try these on your own, and pause your video and check back for your answers. Use the distributive property to multiply binomials. Notice I've got two binomials here, so I can split this up and I can multiply this first term by everything over here. So I'm going to distribute this first term over to here. So I'm going to have a squared minus 4a. Then I would also have to distribute this 3 to both the terms in the second binomial. So I would get plus 3a minus 12. And then notice here I've got like terms because I've got a, and they're both raised to the same power, so I know I have like terms. So I'm going to combine those. So I have a squared minus a minus 12. Okay, so I'm going to let you try with the distributive property and pause your video and check back for the answers. Okay, so notice that I put this m squared n, and here when I multiplied I put n m squared. M squared and n, it doesn't actually matter which one came first. Technically I should have rewritten this as m squared n because that has the higher power. So my point being that these are like terms and can be combined. So my final answer would be 8m to the fourth minus 25 m squared n plus 3n squared. Oops. Okay, so that can get a little bit tedious. So I'm going to show you another way that I think is a little bit easier, and you're going to see it's a whole lot easier once we start getting past multiplying two binomials. But many of you have heard of the FOIL method. That's great. We're going to talk about that probably tomorrow in class. But for right now, I'm going to show you something we call the box method. All right, so I know that I need to multiply these two binomials. I'm going to set them up in a box. I've got my x and my 3, and I have my 4x and my 6. And I'm going to set this up so that I am in effect multiplying everything just like I was distributing, only it's going to come out neatly in this box, and I'm going to be able to combine like terms very easily to come up with my answer. So to multiply, I'm multiplying 4x by x. It's the same thing I would have done here, x by 4x. So 4x by x is 4x squared. I'm multiplying 4x by 3. That's the 4x by 3. So that's 12x. Here I've got x times 6, that one, so 6x. And I'm going to multiply 3 by 6, this one here, so 18. Notice my like terms are on the diagonal right here, and I'm going to combine those like terms. So my final answer is going to be 4x squared. I'm going to add these two for 18x and my constant plus 18. Okay, I'm going to try that one more time so you can see what that is. This time, though, I took shorthand. X minus 4 squared. Well, what is x minus 4 squared? That really means x minus 4 times another x minus 4, right? I'm squaring this entire base. So I can do this exactly the same by setting this up in my box. I've got x minus 4 up here, and I've got x and a minus 4 down here. X times x, x squared, x times negative 4, negative 4x, x times negative 4, negative 4x, and negative 4 times negative 4, or a positive 16. Remember, my like terms are here on my diagonal, so I have x squared minus 8x and plus 16, and that's my final answer. So I'd like you to try some of these out on your own. So set up the box and do the multiplication, and finally simplify by combining those like terms. Pause your video and check back for your answers. About the box method, and I hear all of you saying, but what about FOIL? The cool thing about the box method is that I can actually multiply polynomials that have more than two terms because I can use that same box. Notice I've got a trinomial here because I've got 3 terms, and I can just write out those 3 terms in my box and very quickly come up with my answer. So I'm going to do the same thing. I'm going to multiply here, and here, And notice along the diagonals, I still have my like terms. And I'm writing over these so you cannot see them, which is probably not good, but all right, so when I combine like terms, I've got an x cubed. My 4x squared and my negative 4x squared are actually going to cancel out. And then I've got a negative 16x and a positive 6x, so I've got negative 10x. And then I've got 24 left over. Okay, so this is the cool thing, is being able to quickly and easily multiply with trinomials or any length polynomial just by setting up the box. And I can have a trinomial here and a trinomial here. It'll work the same. So your turn. Go ahead and try these out. Pause the video and come back and check. Okay, what would a video be without a real-world application problem? All right, and it is important actually that you guys pay attention to this one because we're going to see a lot of geometry word problems. So let's pay attention to the wording here. It says the width of a rectangular prism is 3 feet less than the height. And the length is 4 feet more than the height. So I need to write a polynomial in simplest form that represents the area of the base of the prism. Well, the base of the prism, of course, is going to be length times width. And so I need to figure out what my width is going to be. And it tells me that my width is 3 feet less than the height. So I've got my width equal to height minus 3 feet. That's what it tells me. Height, it's 3 feet less. And then I've got my length equal to 4 feet more than the height. So I'm going to do h plus 4. And so when it says write a polynomial in simplest form that represents the area, well, the area is going to be length times width, or h minus 3 times h plus 4. So now I'm just going to multiply this out, and I'm going to assume at this point that you know how to do that. Use the box method. My answer is going to be, in simplest form, h squared plus h minus 12. And if you can't come up with that, then please go back and rewatch parts of the video. And then it asks me to find the area of the base if the height is 5 feet. Well, if I'm told that the height equals 5, then every time I see an h, I'm just replacing it with a 5. So I know that 5 minus 3 is that width, and 5 plus 4 is the length. So I'm multiplying 2 times 9, or 18. So my area, if assuming my height is 5, is 18 feet squared. All right, so of course we've got problems, and you've got a geometry problem at the bottom. And these are due in your notes at the beginning of class tomorrow.